Hi, this class we will learn about CMOS. So CMOS means complementary metal oxide semiconductor. So last week we talked about NMOS and PMOS. So the NFET or PFET. So the NFET and the PFET have some problems. So like NFET or PFET when it is turned on and it goes linear region or the saturation region, the current flows. So when the current flows, we had learned P is I IV, so it have some power on it. So when we turn on the PFET or the MFET, it costs some power. So so when there are some powers flow up, powers happen. So when there costs some power, um, there are like billion of a transistor on the device, one device. So it costs too many power on it. So our battery will goes very fast. The the scientists, engineerists had thought about some kind of solution. It is CMOS, so the complementary metal oxide semiconductor. So it is some kind of NMOS and the PMOS uh, set of PMOS and the NMOS. So we can draw like this. So the top part will be the PMOS and the bottom side will be the NMOS. So we use the same gate bias and it will be the VDD and it will be the ground. So let's suppose that the VDD are the high. So actually the voltage will be some kinds of analog signal, but let's say it is just some kind of digital signal, like there are only kind of high or low. So, and this part will be the low part. And let's suppose that the NMOS threshold voltage will be 0.5 volt, and the PMOS threshold voltage will be the minus 0.5 volt. So let's have some high on the gate side. So mm, VG and the NMOS, PMOS, mm, VG, and high or low. We can say VG will have some high or low. So the high will be the 1 volt. So and the low will be the 0 volt. So when we have some VG on the high, the NMOS VGS, so the VGS will be the 1 volt. So it is bigger than the threshold voltage. So the NMOS will have some one on it. So one means that it is turned on, and the PMOS will be the high, and the source side will be the source will be this here, and here will be the source. So because it has to be some symmetric structure, so the top part will be the source side. So the VSG will be 0 volt, and it is when we have some absolute on the threshold voltage. So the threshold voltage will be 0.5 volt, and the VSG will be 0 volts. So it is not bigger than, so it is smaller than the threshold voltage, so the PMOS will turn off, so it'll be zero. But when we have some low on the gate side, so the VG will be the 0 volt. So the VGS on the NMOS will be 0 volt. So it is smaller than the threshold voltage. So the NMOS will be zero on the low side. So when we have some VG on a low, so the VSG on the PMOS will be minus 1 volt. So the when we have some absolute value on the threshold voltage, so the threshold voltage will be zero point 0.5 volt, and it is bigger than the so the VSG will be with it will be bigger than the threshold voltage, so the PMOS will be 1. So in this table, uh, when we have some high on the gate side, the NMOS will turn on and the PMOS will be turned off. And however, when we have some low on the gate side, like gate or VG, the NMOS will be turned off and the PMOS will be turned on. So it will be like this. So this will be the high on when we have some high on the VG, and this will be the NMOS. This will be the low when we have some low on a VG. So the in point of on view of a circuit, the series circuit will be open, so there will none of current will flow on this circuit. So the I will be the current will be 0 ampere on it, so the P will be 0 watt. So there are none of power will be cost. So this is some basics basic of some CMOS. But we had actually supposed that this is some kind of digital signal, but actually the voltage will be have some continuous value on the when the times flow. So actually it will be some kind of analog signal voltage will have. So in point of curve on it, and this will be VG, and this will be some kind. So it will looks like this. So in some kind of ideal case, it will look like this. It is some kind of unit step function, but actually in realistic case, it will have some kind of time delay on it. So this part will be the MOS for off and PMOS for linear. So this part will be set. So MOS for set. And this part will be MOS for set. MOS for linear. And this part will be PMOS for set. PMOS for set. PMOS for off. So as we look at this some kind of curve, there are parts like this, and the NMOS and the PMOS will have some both or have some saturation region. So It is like this. So the one are on and one are off. So when one goes off and one goes will have some on. So in ideal case, there are like this, but actually realistic case, there are like times like this. So this time there are some kind of current flowing and that time will cause some kind of power. So that can have some problem. So the power is like in the CMOS. So it is like CL VDD square and the F. So the CL will be the load capacitance and the VDD square will be the turn on voltage and the F will be the frequency. So let's think about how to minimize the power on CMOS. So the frequency can go lower, but it is like some kind of trade-off. So when we have some low frequency, the speed of the device will go slower, but in now like modern device, it the speed of the modern device goes higher, so we cannot have some low frequency, so the powers will get goes higher, and the VDD square will have some turn on voltage, so it is related some kind of substantial swing as as we had learned about the substantial swing. So we have to have some solution about the substantial swing, and we can go lower the VDD, so the turn on voltage. And the problem is the CL, so the load capacitance. So in load capacitance, there are some kind of lots of capacitance. Actually, for example, there will be like COX or CDP or some others. But COX will be have to go higher because when the COX gets lower, the gate coupling, so the gate and the channel couplings it gets weaker. So it the couplings when there are some kind of weak coupling on the gate and the channel, it doesn't works well when we have some bias on the gate side. It doesn't send well to the channel, so it have the COX have to be higher. But like CDP or some kind of things will have to be lower. But if we have some kind of it is we called this fan out. So if we have some parallel devices on the part of this, and this will have some load capacitance on it all. So the capacitance when it is on parallel, it have some just plus on the CL1, CL2, and CL3, and it is parallel, so we just algebraic summing, so the powers will get higher. So this is fan out. So it is some kind of problem on the modern devices. So yes, this was some kind. Uh, is basic concept of the CMOS. So next class we will talk about the short channel effect. So we say SCE. So it is the most important part of the um, semiconductor engineering 2 class. So let's see on next week. Thanks to watching my video.